All right, as usual, we've got a lot to tackle today. So but just a quick review from last week. We've been taking a little bit of a historical view of Christianity and seeing how Christianity really has been at the basis of science and getting science, in a sense, off the ground. Because we noticed several things. One, just in terms of timelines, there's just this really interesting correspondence between the rise of Christianity and this very exponential rise in science. And we've had a lot of historians point back to the Dark Ages, the medieval period, and notice that really what got science started was this medieval belief that there is a rational God, and that we live in an orderly creation that was dictated by God, and that He gave us minds for which we can interpret the world around us. And then we also notice some interesting things just over time as we look at various fields of science. We notice that the fathers of a lot of fields of science were Christians themselves. And in terms of award-winning, Christians seem to fill those niches as well. And we look particularly at the Nobel Prize winners. And when we compare that to, survey data that comes out and says, well, only about a third of scientists profess a faith in God, and yet 60 to 75% of the Nobel Prize winners are Christians. So there's this disproportionate, accomplishment in science by scientists who are Christians. So that's really interesting to us. So what we've been doing the last few weeks really is setting a foundation, some kind of basics for these ideas of how faith and science interact. And what we're going to do in the next several weeks is kind of, put things on the ground, rubber meets the road kind of thing. How do we apply these things to contemporary issues? And so today, we're going to start off with this as just a way to work through some issues. Now, you'll have to forgive me because I am an entomologist. My master's thesis was with mosquitoes, so it's not that I love them particularly, but I do find them very fascinating, and I think they'll bring some interesting things to the table. So the question here is there such a thing as good mosquitoes? So, quick survey. How many of you would say mosquitoes are good? Oh, there's a few open-minded people. How many say, no, mosquitoes are not good? Okay. Majority wins. Mosquitoes aren't good. And so the question then is, why are we skeptical? Why are so few people willing to say that mosquitoes aren't good?
They carry a lot of disease.
Okay, carrying disease.
Well, we go back to, almost an assumption that everything has its purpose, God created them, and so there's almost do we want to call that bad? We don't understand it completely.
Okay, fair.
And, yeah.
Good.
Isn't good and bad just our perception of it? That mountain that's out there is really beautiful, and it's good to look at, but if you try to climb it after noon, it's going to kill you.
Right?
That's bad.
Okay, so there are some perspective things in here.
I think a lot of that has to do with a minor discomfort that it produces. It doesn't produce, there is a fear of disease and things like that. But that's almost with any disease, any animal really. But like it's more of a this little bump itches and
So just based on our personal experience, when we encounter them, we're not happy people.
What about Jurassic Park?
So so there's that nasty buzzing in your ear, and when we, especially I remember when we lived in Taiwan, and you'd get to bed at night and you lay down, and there it was, right there, and it keeps you awake, and so we have loss of sleep because of this annoyance, and there's those itchy welts that we get because they visited us more than just in the ear, that they actually take a blood meal. And so what does that do? That makes us restrict our outdoor activities. We don't want to go outside in the middle of the day because we might be more likely to encounter them. But we have more problematic things. We think about loss of livestock. And this is really a thing. We don't encounter it here so much, but in these areas that experience a lot of flooding, so seasonal flooding, or we get past a hurricane or something, well, then, of course, the mosquitoes come out in full force. Well, you might be able to run in your house or your screened porch, but you can't do the same for your livestock. And some livestock in the hundreds will die because of blood loss, because of mosquitoes. Oh, yeah. Now, we know that depredation, even in the tundra areas up north, like reindeer, there is mortality in reindeer just due to mosquito blood loss. So that's a thing. But as was mentioned, disease is something that really is of concern when it comes to mosquitoes. If we talk about the most dangerous animal on the planet, mosquitoes kind of heads above everything else. So malaria, for instance, worldwide there are 219 million cases of it every year. 400,000 deaths every year. Now this is based on the 2019 stats from World Health Organization. And so, it varies. Sometimes it's closer to 500,000. But, I mean, that's a lot of people. And the thing is with malaria, not everyone dies from it, but it's not a fun disease to have. You have these cycles of fever, and it's very debilitating. And when I came back from Africa, I wasn't allowed to give blood for 3 years until I could, in a sense, prove that I was clear from malaria. It takes that long. So malaria is by far the biggest one of concern, but there are others. In Southeast Asia, there's another insect-borne disease called dengue fever, and it affects 96 million, and it involves, it's a form of encephalitis and affects the brain, and it will kill 40,000 people a year. There's also Japanese encephalitis, which is throughout Southeast Asia, not just Japan. So you've got 20,000 people there. Now, do we have that problem here in the States? Well, we do have mosquito-borne diseases here, but ours is what? Pretty small. West Nile virus is what we have here, and about 60 people die every year because of it. So that doesn't make headline news, but it's significant. And then I put another one up here, lymphatic filariasis. Anyone know what that is? Most people know it as elephantiasis. It's a disease caused by a filarial worm that gets into your system, and you've probably seen pictures of it. People whose legs are just absolutely hugely swollen. Now, it's not going to kill you, but it's going to make life really, really uncomfortable. And there are 51 million cases of that every year. Fortunately, we have treatments for it, but nevertheless, this is not pretty, right? So this raises this question of what's called teleology. Now, teleology is this notion that the world has a purpose. Things in the world have a purpose. But there are people who push back against that and say, is this really a way for us to demonstrate that, in fact, there is no God? That there really is no purpose in creation. Things are here just randomly, the way they are. Because after all, if there really was a loving God, would he have made such a thing as mosquito that would be responsible for such death and suffering and inconvenience that we know as humans? Or another way to approach it, you might hear somebody say something like this: how intelligent would a God be who makes something like a mosquito? Is that really, we want to talk about things like intelligent design. Is that really intelligent? Is it? So I think we need to be prepared to answer those kinds of questions, because I think they're real important questions, especially when it comes to suffering. The problem of evil, problem of suffering, is probably the number one question that any religion has to answer, not just Christianity. Any religion must answer this question. And so, how do we address these ideas of theology? Well, I think there's a couple basic responses. One is that when we think about things like, well, a loving God would not have done that. What are you doing there? You're putting yourself in the place of God. You know as much about the world and the way things should run as God does. You must claim omniscience. You need to know everything. That's not a claim I think most people are willing to make. Another thing that we think about is that really this is grounded in a moral claim. And Skip, you were kind of hinting at that a little bit. When we make these categories of good or bad, who's to say that mosquitoes are actually bad? If everything is just evolved and it's survival of the fittest, then golly, the mosquitoes are pretty darn fit because they keep living, darn it. And so who's to say that that's bad? That's just my personal preference, but it truly isn't a matter of good or evil. If you want to invoke that, you can't do that and say at the same time that there is no God. Because you can't ground moral claims in just nature alone. You need a God to do that. So we can kind of start there, but honestly, we can't end there. If we're going to say that there is a God, and he made mosquitoes, we've got some explaining to do, don't we? Right?
Unless you're a bat or a dragonfly.
Well, okay, but we have to address human suffering, right? I mean, good that the dragonfly gets a meal, but what about me? What about malaria? So why would we ever entertain the idea that mosquitoes could be good? Why would we as Christians even think that that could be a thing? Well, it's because what our scriptures tell us. So in Genesis, we have our Genesis passage that talks about God creating everything in the world. And the way that it's written is very inclusive. It covers all the bases. It says God made everything in the world and he was the one who filled it. And what does he say about everything he made? He says, it's good. Well, but that was before the fall, right? Yeah. So the fall explains all the bad things in the world because, physics and biology and everything changed because people sinned, right? Well, that would be a convenient way out, wouldn't it? But here's something that Apostle Paul says. In 1 Timothy 4:4, he says, and this is after the fall, he says, for everything created by God is good. Oh, darn. So we miss out on that one, right? So in this passage, Paul is really talking about restrictions that people were putting on marriage and on certain foods. And he's saying you don't need to have those kind of restrictions. These are things that are made by God. But he's using a broad principle to support his case, to say you don't need to restrict marriage, you don't need to restrict certain foods, because there's this overarching thing that says everything that God made is good. And so while corruption by sin can taint what God has made, it does not stop what God made from being good. So the challenge we have then is this, really. Did God really make the mosquitoes? Well, there's an accounting for this. Because we say, most people, Christians, believers, would certainly be willing to say that God certainly was at work at the beginning. He is what we call a primary cause. He set everything in action, right? But then the question is, what happens after that? So could it be the case that mosquitoes came about by what we call secondary causes? If I knock my book off the chair, it falls to the floor. Was God in control of that? Was God doing that? Or has he put laws in place that are responsible for what we call secondary causes? So could this be a way that mosquitoes can be explained? In other words, did God set something in place like evolution, and mosquitoes are just a product of evolution? They are products of secondary causes, and therefore, God's not directly responsible for that. Or, is there reasons to think that God actually was more directly involved in making mosquitoes? So that's kind of the task for us. We've got, here's kind of the layout here. How do we think about mosquitoes? One way is just to simply say, there's no God. This is proof that there's no God. Or, well, yes, there is a God, but was this by accident, or was it by design? And is there a way for us to tell? This becomes real important because we want to think that one of our arguments for the existence of God is what we call a design argument. We think God exists because there are things in this world that are intelligently designed. So can we tell that? So what we're dealing with here is what we call competing hypotheses. And this is often how science operates. Science does not produce very much in the way of deductive arguments, ironclad arguments, because there's always kind of this unknowingness in science. So we can often make inductive arguments, but very often what we're dealing with are competing hypotheses. And so what we have to do is we take a look at what we see in the world, what do we observe in the world, and we have different ways of explaining what we see in the world. And so we have to balance these things out and decide which set of explanations best fits what we observe. So this is what we call multiple competing hypotheses. So here's the two I want us to think about. One is this possibility, that mosquitoes were able to get their good blood-sucking ability because of evolutionary processes, and God's off the hook, okay? Or intelligent agency actually is a thing. God intentionally made the mosquitoes ready to suck your blood. Okay? So there's a few features that we're going to take a look at. And they're not the only things to look at, but we're limited on by time. So we're going to look at mosquito mouth parts. All the things that are required to suck your blood. So there's mouth parts, and then there's also a pumping system that is involved. So we're going to take a look at both of those. And then we'll lay this out and see what you guys think. Could these things have come about by evolutionary processes, or do we think these are indicators of intelligent agency? Yeah.
We just back up on the intelligent design. So if we're using the premise of intelligent design and just accept everything there, and we're not putting any value judgments on the good or the bad of the science, is intelligent design, is that God's intelligent plan to design a world for only us to live in, or for things to be good for us, or is this God's plan to design a world that is a multifaceted ecosystem and we're just part of it?
Okay, so you're jumping way ahead of me, Skip. Way ahead of me. But that's an important question. Because when we think about intelligent agency, we're thinking about a plan. And then we also have to think about how do we fit into that plan. All right? We'll come back to that. Hold that thought. All right? So, let me jump back to a little biology here, okay? So, I don't know how much you've looked very, very closely at insects, but insects have very intricate mouth parts. I was really pleased and heartwarmed when a coworker of mine posted a picture of a katydid on her Facebook. And it was on her windshield, and she was just marveled at it. She's a French teacher. She's not a science teacher. She's a French teacher. And she was just marveling at it because, there it is on her windshield, and she could kind of, look really close, and she could see the little mouth parts moving and everything, and she was just fascinated by it, like, yay. But there is a lot of intricacy there. So this is a grasshopper. A lot of insects have what are called chewing mouth parts. And we think of, in terms of, evolutionary history, the most primitive insects had this kind of mouth part. So we have, on the top here, we have the labrum, and on the bottom, the labium. And these are more flap-like appendages. And they're more for helping the food get into the mouth. All right, they don't have any hands, they can't pick anything up to eat. So their mouth parts are it's not just for chewing, it's also for helping to get stuff into the mouth. So the labium here has these little finger-like appendages that help moving and manipulating the food and moving into the mouth parts. Same thing with these maxillary pouches. We've got these opposable projections here that they can move and manipulate and, get this food into the oral cavity. And then same thing with the labrum up here. It's just like a flap just helping to push stuff in. And then here's what's doing all the work, the chewing. There's the mandibles. And if you ever, dissect a grasshopper, these are really pretty impressive. They have sharp edges on them, and they're just, good for cutting and grinding. I'm glad your finger doesn't fit in there. Okay? So these are some really basic mouth parts for a lot of chewing insects. But what we're thinking about is, okay, what do mosquitoes have? Now, most of you have looked at a mosquito, and maybe you've taken a few moments to look at them while they're sucking your blood before you swat them, right? And so we all know that they've got this proboscis here that they're sticking in. But there's a lot more there than what you realize. That with what you and I can see, It's actually made up of a series of little stylets. They're very, very small. And actually, each of them has a function. So I'm going to take you through a quick walkthrough here of what all of these different parts do. So realize that just in terms of size, each of these stylets has a diameter of 20, anyone know that? Micrometer, 20 micrometers. That's less than a diameter of human hair. Really, really small, okay? So let's talk about, first of all, the labium. So this lower part here. So the labium here actually acts like a sheath which encloses all of those really, really small stylets that we see in the mouth part. And when that mosquito goes to take a blood meal, it actually moves out of the way. It does not actually get inserted under your skin. So you can see in this diagram here, all the stuff's enclosed in the labrum here, labium, and it's moving back, and all of these stylets are going under the skin, and this is a blood capillary here, where all the stylets are moving into a small blood capillary. So then, two of the stylets, there's a pair of them, called the maxillae. So I've highlighted those here in blue. And these are important because they're doing some of the cutting. So you've got to cut some tissue out of the way to be able to insert and get down into that capillary. So we've got to go through the skin, through that epidermal layer, and into a capillary. So here is the tip of one of these things. Isn't that amazing? And if you didn't know it was a mosquito, you might be tempted to look at that and say, that's beautiful. Just a painful, right? Well, forget about the moment that this is getting stuck into you, right? But look at how those serrations are formed on there, just like the serration on a knife, right? And so this is the serrated edges are actually going to be cutting through your tissue to get down into your blood vessel. Then the next section I want to talk about is this labrum. Now remember, on the grasshopper mouth part, that's that top flap, right? Top flap. Well, what is it in a mosquito? Well, in a mosquito, this top flap has now become this very long U-shaped grooved structure. And this is where your blood is going to flow up into the mosquito, in this channel. And here's a very recent photomicrograph of one of these. And so you'll notice a very, very sharp pointed tip here, which is good for puncturing and getting through the blood tissue. And then here's this groove where the blood is going to be flowing up into the mosquito. Now, in addition to having this sharp cutting edge, and those maxillae that we saw before, they're going to be laying on either side of this, okay? So we have that initial sharp point to get through, and then we have the serrated edges along the side to continue moving that through. But this labrum also has sensory hairs on it. Because where does this labrum have to go? It has to find its way into a capillary where blood is flowing. That's the target. Well, how do you find a capillary? So these sensory hairs are sensitive to a particular blood protein called 4-ethylphenol. Now that's a fairly recent discovery where they finally figured out what chemical in the blood is this honing in on. But like most insect sensory, it's about concentration, And they move towards, where we get greater and greater concentrations of some stimulus. So it has little sensory hairs on it that help it find its way into the capillary. And what's interesting is that this structure actually has become the inspiration for some human design. The photomicrograph that I showed you came from a work done by some scientists who are looking at how can we take biopsies of tissue without causing pain. And they thought, I noticed that when I get a bite from a mosquito, I really don't notice it most of the time.
When it's happening.
When it's happening. Usually you are completely unaware, and it's not until you go, oh, there's a little itch on you didn't even know that the mosquito had taken a blood meal from you. So they said, well, what's a mosquito got that makes that possible? And so they actually are working on doing microprinting of biopsy needles that follow this design to be able to go inside your body, take a biopsy painlessly. Interesting. So then so remember those chewing mouth parts from the grasshoppers. Okay, well, what have they become in a mosquito? So they don't have a chewing structure. They've actually just become these very flattened paddle-like structures. And so here's a series of the different mouth parts here. Here's the maxilla here, but here's the mandible. And it's just this flattened stuff. And what it's good at doing is pushing stuff out of the way. So as we're pushing through tissue to get into the blood vessel, we have another mouth part that's kind of pushing stuff out of the way. And they also then will help close off the food canal. So here's the labrum here. Remember, it was just kind of that U-shaped groove. And so these mandibles also form a covering for that and make it a solid tube. And then there's another part, which is really interesting, which is called the hypopharynx. Now, we didn't see that in the grasshopper diagram. This is often referred to as an insect's tongue. Okay? But what does it do with this hypopharynx? Well, in the hypopharynx, it's a small tube that is actually going to insert proteins into its host. So while blood's coming out, it's pumping something in. Well, what is it pumping in? Well, two things. Let me just show you where it's at here. You can make sense of all of this. So here is the labrum here, that U-shaped tube. Here's the mandibles here that are helping push stuff out of the way. Here's the maxilla here that are doing the cutting. And then here's our hypopharynx here. So this structure here, and here's this little opening right here where it can inject these proteins. And these proteins are of two kinds, not just one kind. One is an anticoagulant. Because your physiology, if you disrupt tissue in your blood vessels, there's a cascading biochemical pathway that will cause blood clotting. And it happens very, very quickly. We don't want to bleed out just when we get a scratch. Well, that is going to create a problem for a mosquito, right? Because if all of a sudden you're clotting blood that you're taking up in your labrum, well, then it's going to clog things up, right? And it's going to clog up the hole that you're trying to take blood out of. So mosquitoes have figured out how to produce an anticoagulant to stop this cascade, of biochemical cascade of clotting that we rely on to survive. And it also contains a vasodilator, which means It's going to open up those blood vessels to maximize the flow of blood. So the mosquito's job can be quick, right? So very, very interesting. What do you think so far? Yeah.
So I was going to ask you on that micro needle, if you got a biopsy with that thing, would it cause you to scratch?
No, because the reason you're scratching is because these proteins that the mosquito injects, your immune system will react to foreign proteins. And that's why you're getting the little welt and scratching. And actually, your scratching is a way to stimulate blood flow. So there is something to the scratching. That's a good thing. Stimulates blood, because anytime you get damaged, we want to repair it. How do we repair things? Well, we get more blood flow in there.
This looks like a pretty intelligent design here. A lot of parasites live off you for a while. This looks like a pretty good plan.
Right.
Something went wrong somewhere.
Yeah. The other thing I was going to ask is, how does air pressure come into play in this? It just seems like we have more blood pressure. Wouldn't it just fill up the mosquito?
Okay, well, here comes the next thing then.
Okay.
So this is about fluid pressure. Okay, because there actually is a problem.
Yeah.
All right. What are we doing? We're taking a straw. Basically, we're taking a straw and putting it in a stream. You've ever done that? Take a straw and you put it in a moving stream. Does water come shooting out the stream? Coming out the straw? No, you just put a straw in the stream.
No.
Why not?
Air pressure outside.
Gravity.
Not gravity.
Well, you're siphoning, you have to take out the vacuum, create a vacuum.
First law.
Two surfaces.
First law. Says what?
Objects in motion.
Objects in motion tend to stay in motion. They're going to go in this direction. They're going to keep going in this direction. So you put a straw in the stream, is that going to make that water change its direction?
No.
No. So continuing with Newton's law, you need what? Unless some other force acts upon it.
So if you were to take the straw and put it in a stream but create a vacuum up here, then it would come up, right? Wouldn't?
This is what comes next.
Oh, okay.
So not only does the mosquito have to have the ability to invade your blood vessel, it has to be able to create a pressure that will draw the fluid in a different direction than the one it is going in. So, and I put this picture in your handout here. So this is the tube that's going down into the proboscis, the labrum. Okay? And so all of this is inside the head. So this is the mosquito's head here. And here you can see its antennae coming off of here. And here's the mouth parts coming down here. And so here's this tube running through its head where the blood is going to flow. Okay? And so there's actually a double pump system inside the head. So here is what's called the subarial pump. And then there is a pharyngeal pump here. And right here is a valve. Yeah. Be impressed. There's a valve there. Okay? So how does this work? So this looks really messy, so let me walk you through this, okay? So here's the subarial pump here. And there are muscles that are attached to the inside of the mosquito's head that pull on the subarial pump, so it enlarges it. So if you increase the volume, you decrease the pressure. And everything in fluids goes from high pressure to low pressure. The universe hates a vacuum, right? So we're creating low pressure here. And then remember there's a valve here. So here's the pharyngeal pump. And there are muscles coming off of that that also it caused it to expand and pull fluid into this part. So these two pumps these sets of muscles will contract alternatingly. So this one fills up by this contraction, then these muscles contract, draw the fluid in here, but then it can't move back here when this contracts again because there's a valve. Neat, right? Gets better. Because a study that was done just a couple of years ago noticed that there are two pumping mechanisms that the mosquito uses. One is if the mosquito is just going to drink water, no sense of urgency here, and it has a very economical, very slow-rated pumping system. But when the mosquito is taking a blood meal, it has what they refer to as periodic bursts or burst mode pumping, and we can see that's recorded here. That will, in terms of energy, less efficient, but it's going to greatly increase the rate of movement of the blood into the mosquito. After all, this needs to be a quick job, right? In and out as quick as possible. So I find it very interesting, that you've got these, it's not just that you have a pump system, but when blood becomes present, when there's sensors, and there are sensors in the mouth parts of the mosquito, when it detects that there is blood there, it will shift its mode of pumping. And one more thing. So we think about pressure, right? We've got a lot of adjusting pressure. What's going to happen with the mosquito's head when you have all this shifting pressure going on inside it, plus all these muscles pulling on the head? So guess what you have?
A headache.
A headache? Right?
Same thing that's happening to my head. It's
Right. So, and this impressed me. One night I was just goofing around in the lab, and I thought, gee, I wonder what the inside of a mosquito's head looks like. And so I took a mosquito's head and I put it in some potassium hydroxide, which is good for clearing out soft tissue, and it'll leave the exoskeleton behind. So you soak it in there for a while, take it out and look at it in a microscope, and what do you see? Well, you can see then clear through to the inside the head and see that there are these struts inside the head that keep it from collapsing. So here's that pump system going through here, and here are these rods that are attaching to the mouth parts because there's a lot of pushing and pulling on these mouth parts to make them move and get inside your blood vessel. And I just think, so they're called tentorial arms. Most insects have tentorial arms inside their head because there's just a lot of pressure going on inside there. But just the whole thought that these are inside a mosquito's head. And how big is a mosquito's head? Like a millimeter. Okay, and all this is going on inside a mosquito's head. So here's the question for us then. Can we explain this by evolutionary processes? Realize what the demands are for evolution. The idea behind evolution is that we have these small incremental changes that have to occur, and they're occurring because of random mutations. By chemical exposure, ultraviolet ray, by viruses, something's coming in and it's damaging, literally damaging the DNA, and we're getting something productive out of that. But each of these things, each of these mouth parts, for instance, are controlled by different genes. It's not like you change one gene and all of a sudden you get an entirely different set of mouth parts. Each one of those 6 different mouth parts is controlled by a different gene. So it's not just that you get one lucky mutation that gets a change, but you have to have coordinated mutations. All of these have to line up together, and they have to confer some advantage. The grasshopper's mouth parts work fabulously. So if it's going to alter, every alteration has to be better than what it was before for it to persist in the genome. And here, the other thing, when we think about evolutionary processes, though we recognize they exist to some degree, there's no teleology here. There's no forethought. There's no future thinking that says, hey, wouldn't it be a good idea if we could access blood as a food supply? Yes, that sounds like a great idea. Let's do X. None of that. That is not built into evolutionary processes. There is no forethought. What are all the different changes that we need to make to move from a set of chewing mouth parts to these highly articulated, highly coordinated mouth parts that we see in a mosquito? That seems like a tall order, doesn't it? But if we think in terms of design, is there a reason for us to suspect intelligent agency going on here? Well, I think there is, because we have some experience that tells us when intelligent agency is happening. So one is we have this idea of irreducible complexity. That you've got some system that's at work such that if you take away one part, the whole thing fails. So take away the hypopharynx that's delivering the 2 proteins. End of story. You're done. Take away the maxillae that have the ability to cut the tissue and get you into. End of story. Right? Take away the sensory hairs that are on the labrum to get you into a blood vessel. Doesn't matter if you've got all the other parts. So you take away one part, we're failing. And so we know that that irreducible complexity is something that occurs when intelligent agency is in action. We also have what we call interdependent systems that are involved here. So, for instance, we've got mouth parts. Well, that's part of the exoskeleton. But you also have to have glands somewhere completely separate from your exoskeleton that are producing the blood proteins, the vasodilator and the anticoagulant to go in, right? So by having all these interdependent systems, again, that is a sign for us that there's intelligent agency going on. Another thing is that one of the things we know about evolutionary processes is that they're really not good at innovation. What does evolutionary processes do? Well, you take something that exists and you modify it slightly for some modified function, but not a new function. And what we see happening here with the mosquito mouth parts is a vastly different function than, say, what a chewing mouth part is doing. So we don't see that. So where does innovation come from? We recognize innovation occurring because of intelligent agency. And another thing is the whole idea that it inspires human design. So I talked about the biopsy mechanism that they're looking at developing. And where they get their inspiration for that? Whereas it's always said, a good engineer is someone who just copies nature, because nature has kind of gone before us. So then, where does that leave us? Where does that leave us? I hope you're mildly impressed here. Mildly impressed. So would we say it is reasonable to attribute the design of a mosquito to an intelligent agent? Is that fair? Okay. This is not if we're weighing out hypotheses, which one seems to make most sense? This happened by random mutation or intelligent agency? I think we're weighing out intelligent agency, right? All right. So, but then here's where the sticky wicket comes, right? Because if God made mosquitoes, right, he says everything's good. How could in what way could we possibly consider them good?
You did mention that's to learn from whether draw blood without causing pain or take biopsies.
Okay, all right, so yeah, so there's something there. Yeah, it's good.
Isn't there a little bit of, not a disconnect, but we've got an intelligent agency, an intelligent, all same designer, and then that value judgment of if they're good, that kind of comes from the loving God. So it takes that loving God to assign a value, whether it's good or bad. I might say, okay, intelligent design made my body, but a loving God would have probably given me a second pump in my head so I could suck a milkshake through a straw.
Exactly. Especially those really thick ones, Doesn't matter how fat the straw is, can't get it through, right? So I think you're making an excellent point. And that is how do we define good, right? Yeah.
Well, you know that there are mass migrations of birds that go to the northern latitudes, and they feed off these mosquitoes at certain points of the year.
Some do, yeah. It's like swallows, for instance.
Yeah. So I guess you could argue that it's got to be good because the birds get fed. Now, is it good that the birds are alive, right?
Okay.
So it's kind of a ripple cascade
Right.
and domino effect.
Right. Okay. So because we're running short on time here, let me first of all make sure we're clear on Scripture here. Okay. From a scriptural basis, what do we think when we're saying that something is good? Okay. So here's a passage. Psalm 148 is really good on this. We have to set things in a really, really clear perspective in terms of God's creation and what it was created for. And even though we look at the creation narrative and we see that humans are kind of like an end goal, kind of, the bigger purpose is much larger than us. The creation wasn't made for us. Okay? It was made to do what?
Praise his name.
Praise his name. To praise the name of God is the reason that all of creation is there, both animate and inanimate, which is interesting about that psalm. That's a whole other discussion. But the whole idea here is that creation is established with intention. God had a purpose for it. And at least from the psalm, it said it would be that he would be praised. Everything is going to be praising him. Now, of course, quick question. Don't want to sideline too long on that. Isn't that kind of vain?
Sounds like it.
Kind of sounds like it, right? Isn't that kind of vain? That you made everything in the world to praise you?
Look at it the other way, too, that what is created by a loving God is by a loving God who wants to give us those things so that we can live and prosper and flourish.
Okay, so we have to think about what is the object here. If God is the best thing going in the universe, then saying that the whole universe is going to praise you is not vain.
It's true.
That's looking out for your best interests, right? I want you to praise me and have a relationship with me because that's the best thing going on in the universe. And that is not vain.
Well, and it's true. If he is the man, and there is no one that can compare, It should.
Right.
Yeah.
I mean, this is looking out for your best interests. I want you to have the best experience ever in your life. And that involves praising your Creator.
Maybe. Okay. Vanity is a human aspect.
Right, right.
I think also it tends to want to humble us. We think, oh, we know all this other stuff. Well,
Yeah.
how much do we know? We don't know how to take and make something so fine like that needle. Can we manufacture that? Not very well.
No. It'll be a poor copy.
It'd be a very poor copy. So basically, he humbles us to let us know how much he did for us, and also show that there's a way that we can make things better for other people,
Possibly.
possibly
Right.
by studying it and using it properly.
Yeah, right. Well, here's another one. We're familiar with this passage, right? And we know that for those who love God, all things work together for good for those who are called according to his purpose. Well, that sounds neat. God wants my life to be happy, and I have a car I want to drive, and he's going to make everything good in my life. Is that what that verse is saying? No. Let's not forget the context in which Paul wrote that. He was writing this to the persecuted church, the church that is suffering. And he's trying to give them confidence in knowing that even though bad things are happening to you, God is not out of the picture. He is working for the good. And what good are we talking about? The good Paul is referring to is not my comfort and convenience. It's his purposes. He is working through history to accomplish his purposes. And so good is not my comfort and convenience. Good is what God does. God is accomplishing his purposes. And then one of my favorite passages is in Colossians. It says, "For by him all things were created in heaven on earth, visible and invisible, whether thrones or dominions or rulers or authorities, all things were created through him and for him, not me." So again, creation is established with intention. He has intentionally made everything in his good creation, and it's there to accomplish his purpose. And what does it say later on in Colossians? It says, all of this is to do what? To reconcile all things to himself. He's going to use these things to accomplish that purpose, to bring about reconciliation. So when we think about purpose, what purposes could God have for mosquitoes? Now here I'm going to run through this really, really quickly. It's things to think about. This is not authoritative. Okay? Because I'm not going to pretend to know everything about the mind of God. I'm going to stand in the humility of Job, who got the thrashing from God. In Job 38, who says, in a very lengthy passage, basically, where were you when I made all these things? That you are so smart that you think you know it. Okay, so I'm not willing to be there, but let me just throw out some suggestions. Okay, so this is plausibility. I'm not saying this is so. Fair? So one is we think about ecological purposes. God didn't just make us, he made all the world and all the ecosystems, and guess what? They are systems and they work. So how do mosquitoes fit into ecosystems? And so from the ground up, those larvae that you see them floating in the water, they are food for a lot of things that live in the water. And they're also part of the decomposition process. They're feeding on dead leaf material, for instance. They're breaking down stuff in the water. So they have a role as a decomposer. And then the pupae, which they're fascinating because they're one of the few insects in the pupal stage that actually move. Most pupa although they're bioenergetically very active, transferring from larva into adult, they're just sitting there. They're not moving. These guys can move. These little horns sticking off their head, those are air tubes, so they'll sit at the top of the water so that they can do gas exchange. But you know, if a shadow comes across or something like that, danger, danger, well, they will swim down to the bottom and get out of harm's way. So they actually can move in the pupal stage. But they're also food. And then the adults, as Nita mentioned earlier, bats and dragonflies really enjoy eating mosquitoes. We go out in a rice paddy and in the evening, you'll see all the bats flying around. Well, they're eating mosquitoes. But male mosquitoes actually are pollinators for some plants. So they're not sucking blood, it's just the females.
Of course.
Of course. No commentary there.
I didn't say that.
And then there are also disease vectors. We don't like to think about the disease, but in terms of ecosystems, one method of population regulation is disease.
Yeah.
It's the thing that helps lower populations so that you don't have mass starvation in a population. So there's a little bit of kindness in the spread of disease. It causes a few to die instead of many to die. So,
Question are certain people, they say one person's more susceptible to something than another, so then you have eliminating the weaker out of the species by nature.
not necessarily. Sometimes nature isn't quite so selective.
Oh, I was just curious. If
No,
something.
no. We know like lions, for instance, they will take out the young and the sick.
Yeah.
But then you have other predators, for instance, who just feed indiscriminately. Just they're opportunistic feeders, whatever comes along. But
Someone get mosquito bites and has in the same grouping, one person have a different being bit 100 times versus another person.
well, so for instance, we know people who have sickle cell anemia, which is a bad disease by itself, causes them to be very resistant to the malarial parasite.
So so there has to be an effect, cause and effect.
Yeah. So another possible purpose is historical. And we know from Scripture we have some good examples there. So we know, for instance, God moved in Egypt, and in the plagues that were numbered there, several of them involve insects. And one mentions flies. Now, Hebrew is not very specific on taxonomy, so we really have no idea what kind of flies this might have been. But the whole point that God is using insects. And if you read through Jeremiah, he's very clear how he's going to deal with both the nation of Israel and the Babylonians. And that he's going to use pestilence. He is going to use disease to accomplish his purposes. There was a book that came out a couple of years ago, hit the New York Times bestseller. Anyone ever see that on the bookshelf? New York Times bestseller, The Mosquito. And this is written by Dr. Timothy Weingard. He's actually a history professor out at Mesa University in Grand Junction. So cool that he got bestseller book. But what he does, this is a history book, but what he does is he walks through history and demonstrates how many times the course of history shifted, not because of military prowess, but because of disease spread by mosquitoes, like malaria. Because even the historical record, they will describe the disease that people were experiencing. They didn't know it was mosquitoes who were responsible, but the disease that they're describing was malaria. And so, for instance, the whole Greco-Roman world might never have come to play had the Persians not been thwarted in trying to conquer Greece. Why did they fail in that attempt? was because their armies were infected with malaria and they couldn't mount their attack on Greece, and therefore Greek culture flourished and spread. And so the whole long list, all these different places where mosquitoes played a really pivotal role in history. So there's a thought. Another one is ethical, and a couple people have mentioned this. One is our need to develop compassion. How do you do that?
All the things that we think are terrible.
Right. If there was no suffering in this world, could you develop a sense of compassion? Because this is a key part of God's character, right? We're supposed to have been made in the image of God. God's training us up to be compassionate people, but if there's no suffering, how can you have compassion? So could it be that? And so, it's our ability to care for the sick. Can we discover treatments? So I don't know if you saw in the paper, big news, they're testing this out, there is a vaccine now for malaria. Not only targets this one particular parasite, there are several parasites that can be involved in malaria, but the big guy, they think they have a vaccine for now. So we'll see how that goes. So that's interesting. But do we devise ways to control or eliminate the vector? And, do you drain the swamps? That's what happened in the Panama Canal, right? Drain the swamps and we get rid of things like malaria and yellow fever. Or do we eliminate the vector? Now, there's some genetic research that's looking at ways to wipe out mosquitoes altogether. I won't get into that, but there are some genetic ways. But this brings in ecological concerns. Okay, if we cause extinction of a mosquito because we're trying to get rid of disease, what are the unintended consequences there?
No idea.
We have, that's why they're unintended, right?
Crazy.
Right? We don't know what horrible things might happen because you pull mosquitoes out of this niche. What fills it? Something worse.
Well, one of those things, an example of that would be DDT. The mass spraying of DDT to kill mosquitoes and other insects had devastating effects on birds and people.
Right. So we've got those issues that we have to deal with. And then last, I'll suggest to you there are some theological reasons. One is this reveals God's presence to us. Remember, there is something we refer to as the hiddenness of God. God does not make his presence known to us absolutely, does he? There is a certain amount of hiddenness to God. And I think for good reason. Because he wants to give us a choice. And if he revealed himself to us fully, so that we could not make a choice, then we're not making a choice at all. But are there things that he puts in his creation to let us know that he's there? And I'm suggesting that the mosquito does that for us. And we're not cherry-picking the data. We're not just pointing to things that we like and think are cool. We're seeing something like a mosquito that we're not liking so much, and yet we can still look at it and say, look, here are these earmarks of intelligent agency. And whether we like the mosquito or not, we know that something more is going on here than just chance, right?
Carl, why does a mosquito pick some people and not others? For instance,
Big mystery.
They bite me and my sister never gets bit.
Big mystery, big arguments. No one knows.
Bananas.
Bananas.
I don't know if
Is
it's trying to eliminate me.
is it the amount of CO2 that you're putting off of your skin? Is it a certain odor that you are putting
that's
off?
what I was going to say.
Is it something you ate just before? And we know that sometimes, if you eat certain foods, then your skin might be putting off certain odors. So is it what you? No one has a clear read on that one. That's a good question. No one knows. Yeah.
Could you substitute the word COVID-19 teach the same lesson and come to the same conclusion?
Yep. Yes, I could. Because I think there's really good reason to think that viruses are products of intelligent agency. And we won't go into all the whys for that.
Okay.
But scientists are very hard pressed to explain how a virus could have come about by natural processes. And all viruses, not just COVID-19, would fall under that. Yeah, we don't like them, but yeah.
Well, I have a question. I was just talking to a physical therapist this week, and she was saying how complex the body is and how awesome it is. And I said, well, yeah, that's one evidence of God. And she was going, oh, no. You know, she believed in evolution. And I tried to say, well, you know, if you have one part, but not all parts, they don't work. And I was saying, if you don't have a kidney, and she goes, well, the first organisms didn't need kidneys, maybe. And she said, but they had millions and millions of years to change. I mean, do you have like a short handout or anything? Give her or something?
People are just in denial, man.
No, my goodness, you go back to the first bacterium that we think was on Earth 3 billion years ago, and it is so complex. To sit there and think that could have just been spawned by chemicals floating around is ridiculous. So.
Sometimes I think the scary part is that we were put here. And so when we create the cascading effects that you were talking about earlier that are so horrible and can basically sometimes create worse things, it comes back to the same thing. God put us here. It's a good design. It probably should have happened. It probably happens. It's going to happen for a reason. So it's hard to think that like when we do something to screw up that design, that it wasn't intended as well.
Yeah.
Well, I think as an engineer, I look at something, we design something, we have different choices to make. If you have to make a choice by rolling the dice, and if you roll the dice, then that takes this item. If you roll it, and you roll a dice and it comes up with something else, that takes another item. But how does that make it come together?
Yeah.
It doesn't, because you have to have a plan, a purpose. You have to understand what's going on, knowing that there is order in the earth. You know, if there is no order, like one of your other lectures, there's no order that they can see stuff, then why bother studying it?
Right.
But if there is order, and the more we know, the more complex things are, the more we understand, hey, maybe if we took and made this work a little bit better. For instance, well, just like a water spray, you know, if you take and spray water out of a nozzle, it just kind of goes out. It's very hard to concentrate it. You know, you can't concentrate it like a laser light. But they discovered, by studying anatomy, that if you put a certain shape on the end of the spray, it makes it spiral and makes the stream makes the stream stay together.
Yeah.
And they discovered that, and they experimented with it, and it works.
Right. And probably because they saw some insect or something could do that.
But, yeah, they saw a way that it worked.
Yeah.
And they put two to two together, and they said, "Wow." When I understood that, that's pretty neat.
Yeah. Yeah. Well, so then the last point here, I think this is a way for us to have confidence that God actually is involved in history. That God is willing to invade his creation and do things in it over time. And not just in human history, but biological history. How long ago did mosquitoes appear on Earth? Long before humans. And God was working then, and if he was working then it's fair to say he's working now. God's willing to invade his creation and make alterations. Now, is he changing the laws of science and things to do that? No. He's using the very laws that he made all of creation with to change things. We're not breaking laws, right? All right, we need to get out of here. Let's think on these things. God, we do thank you that, one, you have made your presence clearly known to us in the way you have designed things in the world. And we have some confidence in that you have designs and purposes for history and for us personally. And we thank you that despite the problem of evil, the evil and the suffering that's in this world, that you stand above all that. You are sovereign. And that you, in your sovereign grace and your will, have the ability to take all those things and move history and move the hearts of men in a way to accomplish your purposes. And so we trust you for that, and we will give you all the glory for how this works out, because frankly, God, we don't understand everything. And so we trust you for that. And so as we go now, keep these things in mind as we go to worship you now, that we would be very careful to give you all the praise and glory and honor that you deserve. In Jesus' name, amen.